Hey there, welcome back. This is part two of our lecture series for today, or for this week rather. And we left off here talking about seafood choices, and just to review, we can, looking at our consumer choices, we can avoid overfished and depleted food stock by what we buy. So in the US, we don't eat shark quite as much, but some cultures use that in different soups and stews, but we do use tuna a lot and we do eat shrimp quite a bit. So we can avoid those things that are overfished and depleted, and we can instead consume and purchase seafood from healthy and thriving fisheries. So our farmed seafood, and then Alaska salmon is actually a thriving fishery right now as well. We looked at, I briefly introduced this to show you what choices are best choices, and what some of your lesser good choices are. And the green, they're abundant, they're well managed, they're caught or farmed in environmentally friendly ways. So these are all really sustainable, self-sustainable, and really well-sustained fisheries. So moving on to our topic in this next lecture is going to be climate change. This is probably going to get split up into a couple of different parts, but we're going to use this part from fisheries to segue into some of the other impacts on the whole entire ocean and creatures in the whole ocean. So in the fisheries specifically, we are beginning to understand, and I think we've understood for longer than we're willing to probably say, that fish and other marine species are kind of biological thermometers. And it's a really good way to describe them because if you remember, creatures are either stenothermal or eurythermal. And we talked about that in a previous lecture. And some of them can tolerate wide temperature ranges, but some of them cannot. So if their temperature range is no longer available, they're going to go to a different location. And so this is setting up a situation where we're finding creatures that aren't normally in these locations, and we're not finding them where we usually find them. And so we also are seeing, as a result, the composition of what fisheries are able to catch change. And let's take a look at that. So if we look in our subtropics and our temperate oceans, we've had significant temperature increase from 1970 to today. And so as those temperatures have increased, you used to be fishing whatever the bluefish are here, and you would get a couple that were around but wasn't really what you were fishing. And then as you go along and the temperatures are increasing, your bluefish are decreasing drastically, and your other fish that you're not intending to catch are increasing. This is a new species that's becoming abundant here that really was not in this region before. And then with the drastic increase in temperature, all of a sudden, you are still bound by your fisheries boundaries because that is set by your government, but you're not catching anything anymore. So that becomes a real problem. And so you're getting these warmer water fish that are moving into what historically have been cold water fisheries, because we know that that's where the nutrients are and stuff like that. So that's where our cold water fish go. Now, in the tropics, it's become even more drastic because in the tropics, they were catching their tropical fish with some subtropical fish. And then as temperature increased, now their subtropical fish are going elsewhere. Remember, they're coming over here. And their tropical fish at first were, okay, that's fine, except that I'm trying to fish the subtropical fish. And now we're not getting hardly anything. So fish, it's become so warm in the tropics, fish are going more into your subtropics and your temperate oceans. We're going to switch over to a different lecture really quick, just because it was broken into two different pieces based on topic here. So we're going to switch over to this one and start talking about how climate change is affecting overall. And that is not the right one. I apologize. Here we go. And this one is going to be split into two parts as well. So hang in there. So when we talk about climate change, what we're talking about is human-caused climate change. Human-accelerated climate change is what I would argue. And what we're seeing is that it's having drastic impacts on the ocean environment. And I wanted to give you guys some resources, and these links will also be posted in its learning for your convenience. These take you to really good, reliable, publicly funded sources of scientific information. And the public funding piece is what's really important. And we didn't get a chance to delve into this as much this year, not being in the building. But public funding for research is a really important accountability tool because there are laws in place that govern how public money is used. So when you want to look for publicly funded research, you want to look typically with your orgs, but some .coms are still good, but you just need to kind of dig into where their funding is from. So these two .coms are publicly funded, but they sell product to help fund their research that's unrelated to, and they sell their own product, not something that they're selling for somebody else. So all that to say, there are some good resources for you as you're looking for how climate change might be impacting your creature. So we're looking at some general things that climate change is doing. So over the past several years, we've seen that the Earth's average surface temperature is drastically increasing. And that rate of warming in the last 50 years especially is double that of the past 100 years. So it's really taken off in that last 50 years. Your warmest years on instrumental record since 2000 have occurred in our recent past. And sea surface temperatures are increasing as part of that. And with our increasing heat waves that we're getting, it's affecting our evaporation cycle and our water cycle that we're experiencing. And so in order to keep our atmosphere balanced, the ocean is evaporating off more water to provide that moisture for the atmosphere to keep everything in balance there. And here is what that data looks like. So from recorded history, which was just after 1860, so about 1865, we have increased from here to here. Now, you can see all of these individual peaks and valleys, and these are all natural oscillations in climate change. So one of the things that's really important about this trend line and this set of data is we can see the overall trend, and then we can see all of these natural peaks and valleys that occur normally. Our climate varies. And so we know that, but this allows us to take a much longer term perspective here to see that we're not just dealing with these natural peaks and valleys that our climate normally experiences. We look at the trend overall, and we see a significantly increasing trend. So what that means for us is that we have earlier, hotter summers, we have some more severe droughts in places and flooding in others. Our mountain glaciers are going away, and we have water contamination issues because as water evaporates, concentration of contaminants is going to increase. Ecosystem changes are going to cause the movement of creatures to, especially those that do not tolerate temperature ranges that are very large, which can lead to extinctions of other species because if they're part of their food web, then their food goes away. We also have this increase, and remember we talked about how that sounds good on the outside. We have this increase of biological productivity, but remember that if that's out of control, that actually creates dead zones. And when we have ice-free Arctic water, that promotes that increased productivity. And so we're seeing our dead zones extend into cooler waters where they should not be. Cooler waters should not deal with the issue of dead zones. Warmer waters, it happens, but cooler waters should not experience this. But with ice-free Arctic waters, it's allowing that productivity to just take off. And so we're starting to run into some issues there. This is where Earth's temperature, so this is from mostly since 1970, but taking all that data into account. And if you notice, it is your deep, cooler waters that have seen the largest increase in temperature. So this doesn't mean that they're now the hottest waters. It means that their temperature has increased the most from what their normal temperature is. And then we have other areas that are cooler. So we see these changes occurring, especially in the northern hemisphere around the Arctic Circle. It's completely changing what our Arctic ecosystem looks like. Now, if we look back here, we have increased temperatures across the Atlantic Basin as well. And that is going to increase our hurricane activity. So what that means is it doesn't mean that we have more storms, because our weather patterns and the timing of them has stayed very consistent. However, what we do see is that the intensity of our storms have increased. So the number of Category 4 and 5 hurricanes, the ability to produce multiple strong storms in one season, has increased, and that has caused much damage, loss of life, loss of ecosystem, all of that together. So again, it's not the number of storms that are increasing, but how many are reaching that catastrophic level. And if we think about the energy transfer between the ocean and the atmosphere, if the ocean is warmer, more of that energy is being transferred to the atmosphere. And remember that weather is a balancing act. So if we have more energy to disperse, it's going to take a bigger force to disperse that. So the strength of your storms is directly related to how much energy you're transferring between those systems. We obviously have increasing sea level. We're seeing it along the coast here, and island nations have been dealing with it for a lot longer than we've noticed on the coasts of a larger continent like we have. But we have this thermohaline circulation that's being impacted as well. And we'll come back and kind of talk about these two things together with thermal expansion. So remember that thermohaline circulation is dependent on temperature and salinity. So we did that lab. It wasn't yesterday, but if you remember the thermohaline, I don't know why I can't say that today, thermohaline circulation lab, we saw that temperature has an effect on the circulation where warmer waters rise and cooler waters sink, and that salinity has an effect on circulation in similar ways. The more saline the water, the more dense that it is, and it sinks. So your cold saline water is going to sink to the bottom, and your warm, more fresh water is going to be at the top. So we know that those two create the density of the water and set up that global conveyor belt that keeps our atmosphere balanced, because it transfers all of that heat energy evenly around the world. So we talked about all of these different water masses that are a part of that and how they set up the global conveyor belt. Now, with that, if something changes, so let's say that temperature is now higher, that means that your North Atlantic deep water, if it is now warmer, isn't going to sink like it did before when we talked about that. It means that when you get your Antarctic intermediate water, it's not going to sink to the level that it is supposed to. So all of those, when you don't have that drop off, we talked about the analogy of a roller coaster, especially with the North Atlantic deep water. Remember, there's a really vulnerable spot right at that point in the global conveyor belt. And we talked about how the North Atlantic deep water kind of takes off like the beginning of the roller coaster and provides a lot of the momentum for the global conveyor belt. If that doesn't sink like it's supposed to, then our global conveyor belt is not working properly. I'll see you guys in the next part.